Why yes, I am playing Grand Theft Auto 5 on my Linux box at full speed with no problems at all, and it's great. Alright, so the short version is I've got GTA working, well not just GTA, I've got an entire Windows machine that's living as a virtual machine under Linux. What does this really mean? Why would you do that? Why would you violate the purity of Linux? There's a whole bunch of questions. There's not really enough time to go into it in the videos, but look, the real answer here is that I'm kind of pragmatic. Windows is entrenched. Mac OS is also entrenched. It's here. It's not going to go anywhere. You don't really have to be so exclusionary in that, oh, I'm going to use Linux for everything. Oh, I'm going to use Windows for everything. Oh, I'm going to use whatever. I do have some concerns about the direction that Microsoft as a company is going in, and I'm not really sure that I like the idea of trusting the Windows operating system with the bare metal of my machine. And so I like the idea of being able to run Windows in a virtual machine, but I'm also sort of a performance conscious user. I want the thing to run as fast as possible. Well, on modern hardware, for things like gaming especially, you can pass through the hardware, in this case the video card, to the virtual machine so that you can play a game with a real physical video card that a virtual machine has control of. This is what we're doing. That's essentially sort of the magic here. I would really, if you're going to do this, if you're going to switch to Linux or you're going to actually run things with Linux, really consider that for most things most people are doing, there are good applications on Linux to do pretty much everything that you really need to. It's about 65-70% myth these days that Linux doesn't have software to do day-to-day computation. For elderly people or people that just need a computer as a communication tool and a document preparation tool, Linux is basically there today in terms of web browser and web access and anything that you would want to do on the internet. Linux is basically 100% feature parity with what you get on Windows. Now, it's not going to be exactly the same experience. The applications that you use are going to be different. You're going to have a little bit of a different experience, but how you experience the web, basically that's not going to be any different. How you create documents and work with application software, that's going to be a little different. How you, if you're a programmer, how you do development and things like that, that will basically be a little bit different. You can do really great development stuff, especially web development on a Linux machine. That'll give you a lot more control and flexibility, and it's a lot easier, and the package management is a lot more sane even than, say, Mac OS. And on Windows, well, Windows just has a whole host of problems, and generally Linux works better in that regard right now today. But for legacy applications, for anything that you have to do that is old, or you're supporting a legacy environment or you're doing the transition, being able to run Windows under Linux is kind of a big deal. So with this setup, we can do it. Now this setup, you can actually do it a bunch of different ways depending on what suits your use case. And so in my case, I'm passing through a physical video card mainly so I can play games. If you're not going to be playing games, or you don't need GPU acceleration for programs like the Adobe Creative Suite, like Photoshop acceleration by having a real GPU, or Premiere or After Effects acceleration by having a real GPU if you just want to run the Creative Suite, you can take this approach and it works fine without doing the hardware pass-through, and that'll work on pretty much any computer. The hardware pass-through is something that has worked for a couple of generations of hardware now. Depending on what you got in the Haswell generation, you would be able to do it. But certain parts, especially the overclockable parts, did not have the pass-through capability for hardware. Now they added that back in Devil's Canyon, and also the prior generations had it as well. I mean, actually the virtualization technology goes all the way back to 2005. That's when the virtualization extensions first appeared, and they've been used pretty heavily in the server segments for adding more support for different kinds of things. You actually do see GPU virtualization for virtual desktops now in the enterprise. It's sort of been there for a while, but that really hasn't made its way down to the desktop in exactly the same way. Well, with Skylake, even though these are overclockable parts, you can do the virtualization extensions that allow you to pass through physical hardware, and so we set that up on this particular Linux distribution. The nuts and bolts of how we do that in this particular case, we've got the Intel 915, which is what the driver is called on Linux, for the HD graphics that are built into the Core i5 and the Core i7. The i915 stuff has to be enabled manually at the Linux kernel command line, so you really want to be sure to check out the article on the Tech Syndicate forum that sort of has a little bit more step-by-step of how we set this up. You probably also want to read the Arch forums and some of the other stuff. But to make a long story short, for the setup that we've got here, we enable the Intel i15. There's also some other stuff that we have to enable around the IOMMU. Now the IOMMU sort of gives you memory maps that allow the drivers for the hardware to basically communicate through the virtualization layer to the physical hardware. It's very important that the I/O MMUs are set up in such a way that the devices that you want to give access to the virtual machine are accessible in one I/O MMU pool. We don't want to overlap where you've got one I/O MMU pool, basically a region of memory, where some of the stuff in that region of memory you want to virtualize and some of the stuff you don't want to be accessible inside the virtual machine. That creates a little bit of a problem, and you might have to fiddle with things. Fortunately, for the motherboard that I'm using, the Asus Z170 Deluxe, everything was basically okay out of the box. I did have problems with the I/O MMU for the Intel 915 graphics, and so I had to disable that with another boot time command line kernel thing. I suspect that's a kernel bug, and I suspect that they're going to fix that at some point in the future. But for now, I just added the entry to the command line to fix it up, and because I'm not virtualizing that particular piece of hardware, it didn't really sting too much that I was not able to use the I/O MMU region for that particular peripheral that's built into this motherboard. Now, the other nice thing about this motherboard is that it's got a ton of USB 3 connectivity, and so I'm able to pass through the USB 3 hosts to the virtual machine if I want, so I can expose entire USB ports to the host machine. But if you have fewer USB ports or fewer USB controllers, or you don't want to pass through the physical controllers, you can also pass through physical devices. So you can say this mouse and not that mouse, or this keyboard and not that keyboard, can pass through to a virtual machine. So you can actually use separate mice and keyboards for your virtual machine if you want, and it's actually a little easier if you do that during the operating system setup phase, so that you can switch back and forth between the guest operating system and the host operating system more easily. Now, in the final setup, I'm using Synergy, which is a program that runs on Windows and pretends to be a keyboard and mouse, and I can actually move the cursor off the left-hand side of the screen in Linux, and then the program, Synergy, takes over and says, I'm going to give the mouse sort of a virtual space over here for the other monitor on Windows. I can press scroll lock on the keyboard, and it will lock the cursor to the screen that it's currently on. Same deal with the keyboard. The keyboard sort of ends up being mapped through that software layer to the other computer. The latency is not as good as a physical device pass-through, and so you have other options. Like if you don't like that option and you want to use a USB peripheral switch or a USB KVM switch, you can totally do that. You can take a KVM switch like this, which lets you normally would let you hook up to two different computers, one monitor, mouse, and keyboard. We won't use the monitor part of it. We'll just hook up the mouse and keyboard to the KVM switch, and then hook up both leads coming out of this KVM switch to the physical computer. And then we tell the software that one set of leads goes to the KVM container, and the other set of leads goes to the physical computer. And then so now we have a button for toggling back and forth between the two virtual machines. I've also got the Logitech MX Master mouse. This mouse can actually be paired with up to 3 machines. And so with this, I can use Bluetooth or the little Logitech unifying receivers. And so in this case, with this motherboard, because it's got onboard Bluetooth, I can pair the Bluetooth mouse under the Linux side and then pass through the unifying receiver on the Windows side. And so I can have a physical hardware connection to my mouse. And depending on which computer I want, I can actually just toggle which one it's going to on the mouse. And that works out great for me. To really put the icing on the cake with this setup, I can bind a key on the mouse on both the Linux side and the Windows side, so that when I press the recessed mouse button on the MX Master, it will actually change which machine my keyboard is assigned to. So with USB pass-through, because maybe I want better latency than what Synergy gives me, I can actually just use the MX Master mouse to toggle between the two VMs. But you know, playing a kind of twitchy first-person shooter was actually fine through Synergy. The latency that it added was not much, because it's really the machine just going from one to the other. So you might be thinking, wow, that's an awful lot of headache to go through, having to switch monitors and go back and forth through that. All right, don't switch monitors. You totally don't have to do that. So you can run Steam on Linux now. That's a thing. Steam in-home streaming. Yeah, didn't think about that, did you? So Steam in-home streaming, you're in a situation where you can run games on your Windows machine and stream them to the Linux machine. Yeah, that does take a little bit more overhead to do, and yeah, you've got frames per second limitations and things like that, but if you just want a quick game of Don't Starve, actually Don't Starve works fine on Linux. If you just want a quick game of something that doesn't work on Linux, then you would be able to play that through Steam in-home streaming. You wouldn't even have to switch monitors. Everything would basically just work. Now, you're probably not going to be streaming at 4K, but that is an option. The other thing you can do is not pass through a graphics card at all. You can use remote desktop to run applications remotely, seamlessly. Now, we sort of talked a little bit about getting VirtualBox set up so that you could sort of seamlessly have Windows applications. That is, Windows applications running in a Windows virtual machine are completely indistinguishable from applications that are running on your desktop. That's totally an option with this as well. It's just that you're using KVM for your virtual machine instead of VirtualBox, because VirtualBox doesn't really support the same kind of hardware pass-through. This would also be possible with XEN. It's another sort of hypervisor technology that sort of runs and manages the virtual machines that you would create at a very low level on your particular machine. So we used Arch for this particular project just because I wanted to fart around with Arch. You could totally do this with other Linux distributions. In fact, a lot of the really advanced technology in this borrows from Fedora Rawhide, especially even in the Arch tutorials, like the UEFI that I downloaded and am actually running in the virtual machine. It came from some project some guy put together for Fedora Rawhide. It looks like I had to extract the UEFI from RPM files. The basic steps to recreate this: go to the forum and read the forum thread, because you're going to be doing a lot of reading. Know that this is like a 400 level task. This is going to be a pretty significant task. This is going to be pretty involved. Eventually, in a year or two, there's probably going to be a push button Linux distribution that will do this for you and help you sort of know the caveats of what your hardware is doing, and somebody will probably wrap it up with a nice slick installer. Until that day comes, challenge yourself, give yourself a little bit of a project here and see if you can pull it off, see if you can put it together, because it really is a challenging, interesting thing to do to try to use the machine like this. It's a worthwhile endeavor. Linux has completely taken over the universe pretty much everywhere. It's only a matter of time before it takes over on the desktop. And I think how it takes over on the desktop is going to be exactly like this. It's not going to be that Linux all of a sudden gets Adobe support, or Linux all of a sudden gets support for third-party applications. It's totally going to be that somebody comes up with a really slick emulation layer or a really slick wrapper layer, and then it's totally just going to take over the universe. So step one is making sure that you can enable VTD with the VTX extensions. So you've got to enable hardware extensions for virtualization. We do that in the UEFI on our Z170 motherboard here, and our CPU supports them. If you're not sure if your CPU supports them, you should check the Intel Arc. Really, this video is designed for doing this with Skylake, which is a little bleeding edge. A lot of the other tutorials are for, Haswell or Devil's Canyon chips, and the Haswell chips, if you've got a K chip, I'm sorry, the type of virtualization you need to do for video card pass-through is not going to work for you. But you can do everything else up to that, but you're just not going to be able to play games under that particular virtual machine. Sorry, because Intel disabled the extensions. If you're on AMD, things are a little different on AMD, but AMD generally supports this kind of stuff a little more completely than Intel. I will say that having experimented with this on Devil's Canyon, what I've experienced so far on Skylake has basically been more stable, with the exception of the Intel 915 graphics support. The Intel 915 graphics support, or the Intel HD graphics. It's called the i915 in the Linux kernel, but it's like Intel HD graphics 530 or something on Skylake. So, 6 one way, half a dozen the other. In this case, the i915 support has been a little sketchy in kernel 4.1. So if you're doing this, also make sure that you're using Linux kernel 4.1. Once you've got the VTD and the VTX extensions installed, the next thing you need to do is to check your IOMMU and see if your IOMMU stuff is enabled. So for me, it was disabled. And so what I had to do was edit the boot line. Now, in my case, I'm using the systemd loader as opposed to grub. I figure a lot of you guys are using grub. The Arch tutorial was for using grub, and so the instructions for changing the boot line on your kernel are a little different. I'll save you a little bit of a headache. Ultimately, you're going to have to enable IOMMU, disable IOMMU for the i915, but leave it on otherwise. It seems to take both parameters, although the Linux kernel mailing list seemed to suggest that I only needed one, but I actually needed both parameters in order to see IOMMU entries. Now, if you know you're doing it right, there's a command on the forum that you run, and you check and see, and then it'll show the IOMMU entries, and you want to see if you've got an IOMMU entry that roughly corresponds to your video card. In this case, you can run LSPCI or LSPCI-TV for the verbose tree output version of the LSPCI output that will show you the graphics cards and sort of where they are in the system, and then you should see an IOMMU group that will go with that. So in order to pass through the hardware to the virtual machine, we will have to specify what devices by their PCI Express IDs that we want to pass through, and LSPCI is going to give that to us. We can do LSPCI-NN, and the LSPCI-NN command will give us those numeric IDs. Once we've done that, we can tell Linux that, oh no, we don't want to load the Radeon driver in this case because we're using the Asus 390X, that we want to load the VFIO driver instead. By loading the VFIO driver, this sort of prevents the Radeon driver from loading, and it prevents the video card from being initialized. but the VFIO driver is what the KVM virtual machine, in this case, will actually hook into to pass the commands through to the video card. In order to tell Qemu that we want to do that, we basically need to pass it those PCI IDs. And so I've created this little shell script that has the command line necessary to do that. Now, if you're using a GUI for this, like libvirt, or you've got a libvirt GUI or some other GUI, you can do a lot of this through the GUI, but for some of the configuration, you'll have to do it through the command line. Now, here's the other interesting thing. The virtual machine here has an emulated BIOS, but this card is EFI, and so we want to use EFI mode. This is another thing that you can sort of get tripped up on. I want 1 to 2 second boot times. That means that I need a video card that supports UEFI. It is maybe a little problematic if you're using a video card that doesn't support UEFI. You can still pass it through, but it would be better if the graphics card had full UEFI support. Unfortunately, the Qemu virtual machine doesn't really have full support for that, so we need to download a BIOS that we're actually going to run, that is an EFI BIOS, that will then talk to the physical EFI card. So think about this. It's like we've got the emulation layer that's emulating the hardware. So we've got our bare metal CPU, but then, oh wait, to actually boot it up, we need a UEFI. We can't use the system's UEFI. We need a stub UEFI. Well, normally there's CBIOS, which will give you an MBR boot. We don't want MBR. MBR is so last technology. We want UEFI. So we need a UEFI firmware to boot on the bare metal. So in order to do that, Qemu does of course support that. And so in order to do that, we have to procure the EFI firmware and actually use that. And then with the EFI firmware, it scans the virtual and real PCI Express bus and finds, oh, there's our video card. And then we'll initialize the video card and make sure everything works. So at this stage, I would suggest using a very simplified version of this shell script just to see if the computer will boot to the UEFI, because if it's able to initialize your graphics card, you're going to have a lot better experience. On the prior generation, especially non-UEFI graphics cards, especially on like the Z87 platform, it was really sort of problematic if you wanted to initialize your graphics card twice. Depending on your graphics card and the version of the BIOS on the graphics card, you could actually physically hang your machine the second time the graphics card initialized. Same with the Windows drivers. When the Windows drivers would unload and then you would restart your Windows virtual machine, when it went to start a second time, it was not exactly stable. So it does matter a whole bunch about the graphics card and a bunch of parameters and how the hardware is put together. And in general, because UEFI is newer, UEFI does not generally suffer from those problems, although it can still be really sort of crazy. I mean, if you just want to build a really awesome machine, just stick to the first video. Just build the machine, install Windows, and call it a day. If you want to take it to the next level and have Linux be your main operating system and then switch over to Windows only when you need it, take the pragmatic approach with Windows, then this is completely fine. But I would remind you that Linux is okay. Like, you don't really necessarily have to run stuff. You should not expect to have to do this. If you just want to keep working as you have been and keep playing games as you have been, then you can run all of Windows in a virtual machine, and it's a very sort of pragmatic approach. Linux is great, but Linux is different than OS X and Windows, and if you expect Linux to be just like OS X and Windows, you're going to be disappointed, and you should not expect that. Linux works differently. Linux will make you smarter because it teaches you more about the computer and how things are physically working and doesn't really hide anything from you. But if you need to be able to run Windows applications and you need to be able to play Windows games and you want to learn more about the computer and you don't mind the headache that generates from wanting to do that, then you should do this. This is a really interesting project. If you just want to run Linux and you don't mind learning that things are a little different, Linux is a completely competent operating system for doing anything that you would want to do on the internet, doing pretty much anything that you would want to do in terms of document assembly and creation, certainly anything that you would want to do in programming, especially if you're doing programming with things like Python, Ruby, Go. Those languages work probably better on Linux than anything else. So if you're going to be a computer scientist and you're going to do things with computer sciencey things, even networking infrastructure, the whole 9 yards, Linux is where it's at, and Linux is where you want to be. If you expect Linux to work like Windows or OS X, it's never going to be like that, at least not for a long time. But if you want to run Linux and also have access to Windows and everything else, then this is maybe one way that you can do it on a single box. So if you decide to embark on a project like this, I want to hear from you. Let me know in the forums at techsyndicate.com. There's a lot to this. I've really glossed over a lot. If we were to turn this into a video tutorial, it would probably be about 16 hours long just to cover all of the details and all of the variability. So I've tried to document this a little bit more in the forum. I'm probably going to turn that into a wiki, And I hope that the community will sort of help put that together. Maybe we can have a couple of different wikis for a couple of different distributions. I can tell you, you're going to need kernel 4.1 or kernel 4.2. You can totally do this on Debian and Ubuntu. Fedora Rawhide works great. Arch, those are probably the main distributions that we would, maybe Gentoo if there's enough interest, but those are the main distributions that we would cover in terms of how to set this up. There's also going to be a lot of variability across hardware support. So really, unless you know what you're doing, you really know what you're doing, I would recommend doing this on newer hardware because it works better on newer hardware. And actually, I can't wait for another generation or two beyond this, because another generation or two beyond this in terms of hardware and software is going to be even more advanced than where we are now, and we may actually get to a point where this is just completely push button. And so we'll be able to roll out Linux across the enterprise, and Windows will be relegated to a tiny corner of the machine where, you know, it just lives and does its thing and it's perfectly happy, but it's in its little sandbox and it's contained, because that's really where it needs to be. I'm Wendell, I'm getting ready to sign out, but I want to see the aftermath of you embarking on this project in the forums at techcentric.com. I'll see you later.